going to be our MHP LMG build guide video for our DIY and hardware kits. Everything you need is in the picture here. This is if you got all hardware and the DIY and prints from us. If you printed your own parts or source your hardware somewhere else or bought your own hardware, your results may vary, but these are the tools you need. In the middle, we'll go through those. These are the wires. I pre-cut them to the necessary lengths, and we'll talk about that in a minute. And for our gearbox, we'll have a couple of reinforcements that we like to do because I've stress tested about 6 different LMGs now, and we've solved just about every problem you could have with it. That being said, some of the improvements or reinforcements are optional and you don't need them to make a functional LMG. And for more experienced builders, you may think, hey, why are you doing that? Wouldn't this be easier? And there are certain shortcuts you can make, or things you could leave out to make your build cheaper or faster. But here is the way that I found to be most robust out of the half a dozen to a dozen now that we would have built at the point of this video. Now, that being said, I have only built about 6 or so, meaning there may be some better ways to do things later. So check out the written build guide and the notes, comments, or descriptions of this video for possibly more updated assembly processes. And like always, if you struggle with anything, feel free to reach out and ask and let us know. Heath did an amazing job on this design. Shout out to him. And we helped him do that. When he sent us the files, it was very much not release ready, and then in a matter of weeks we were able to get it ironed out for him, and we are proud to present you the first high performance belt fed compared to all the other belt feds out there, which are modified Nerf or off-brand belt feds. This one definitely has the highest rate of fire, highest reliability, all those fun things. So without further ado, we'll jump into what you need. Of course, you're going to be building a flywheeler, so you have some soldering. So you have to soldering iron, all that setup you need. For all the different screws and bolts and stuff, you will need a 2.5mm hex key for your standard M3 screws. You will need a 2mm hex key if you're using M3 flathead screws. If you are using Phillips flathead, you could use the Phillips instead, which of course you'll need the Phillips for your motor screws. That's about the only Phillips screw. Oh, and your gearbox. So your motor screws and your blue gearbox, if you're doing our reinforcements, you'll need to take that apart. Highly recommended. Actually, might not work without it because of the strength of the pusher gearbox, but rewind all that. You'll need a Phillips for the motor screws, the gearbox, and if you're using any other Phillips heads other than our standard. And then for this, I like to use just a driver on a low torque setting. Seems to work. There's a lot of screws. It makes our time go by a lot faster. And then for drill bits, I've got a 5/64, which I like to use to clean up holes and reinforce the gearbox. A 7/64, which I like to use to clean up holes and to make installing shell screws a bit easier. I will say you will need a Phillips for the shell screws as well. I like to use regular toy shell screws for our tenny switch mounting because they're like a 2.5 or 2.6 size screw instead of a normal M3 screw. And they're cheap and easy to get, and they fit just fine, perfectly, pretty much perfectly, but I like to use a 7/64 to make it more perfect. And then in case you do need to clean up some holes or to adjust our some spring detent depths, we do have the 13/64, which is a good size for cleaning out any holes for the head of an M3 screw. You could also use a 1/4 inch. And then you may also need a 3/16 for your small screws, and then a 5/16 for your wider springs. Sorry, a 3/16 for your smaller springs and a 5/16 for your larger springs. That's just in case your holes came out a little clean and the spring doesn't sit all the way in the hole and you need to clean those up. You could also use a small file to clean those up, which I also like to use for the gearbox reinforcements. You also need a way to cut or strip your wire. I like to just use some pliers and my fingers, or you could use wire cutters and wire strippers as well. I like to also use these to clean up excess plastic off the prints. For installing your motors, you'll need some Loctite or thread lock. Here you go, to keep your screws from loosening up on the metal-to-metal connections. And then we'll also use, let's see, not included in your kit will be tape. I like to use electrical tape because of its kind of spongy property, but anything is similar thickness will work. And then scissors for cutting set tape. Also need a little bit of super glue, not as much as here, just a couple drops. This again, is for the gearbox. And I like to use a file to score up said gearbox as well. A hammer for rearranging the gear set in the gearbox, just to tap those gears on. They're a nice press fit. You can also use it to install your cam gear as well. And then edge deburr to clean up your prints. I also like to use this size of kind of a metal support shaft to support the backs of the motors as I install things, as we'll see in the guide. These are all tools you'll need. So we're gonna go ahead and start by modifying your gearbox, which is gonna be this blue TT 1:90 gear ratio gearbox. It has a motor installed already, but it's pretty low torque, pretty low RPM, so we're going to take that out. To do that, we're going to take our Phillips and remove these 2 toy screws in here. And I'm going to do a little snippet right now for our wire lengths. So our wire lengths, I'm going to build a single stage here. If you're building a dual stage, you typically just add 1.5 inches to your motor wire length. But you're going to have a 14.5-inch red wire for the battery connection to the switch. Then you're going to have a 14-inch wire for your single stage, or about a 15.5-inch wire for your dual stage. Then you're going to have a 26-inch black wire, and if it's a dual stage, something more along the lines of 27.5 is what you want. And then to connect the pusher motor to the cycle control switch is just a 1.5-inch wire. So these are all my pre-cut wires. Take out these screws. We'll take these out. I don't actually like to keep these in. They seem to be a bit thinner than our 12mm toy screws. So that's what I'm going to replace these with later on. You should have 2 12mm, not the 10mm length. And you can see they're slightly wider. They seem to grip better. I have gotten a couple of these toy boxes where if you tighten down the screws, you can easily strip the blue plastic. So I don't like to use these ones. They seem to have a higher thread count on our smaller. So I replace them with the same length, but thicker screws here. Okay, so I'm just gonna toss these or put them in my toy parts bin and use them for a different build. And then I'm going to remove the top cover. Just by pushing down on the axle. There's my gearbox. Take out the old motor. Then I'm going to remove the gear from the housing here. I like to use a pair of pliers or a pair of needle nose and just pull up on the gear and it'll slide off the shaft. Like that. That one wasn't too bad. Then again, you can throw this away or use it for something else. Don't need that. And then I'm going to take one of my new pusher motors. Now, depending on what rate of fire you want, you can use different motors. So this is a Kraken motor. On a 30S, it hits about 3,500 RPM, which is about 6 darts per second. And you can see our graph or our chart. If you have a different RPM motor option from us, a Merlin, for example, gets 74,000 RPM, which is about twice as fast as a Kraken, which gets about 11 darts per second to 13, depending on, some variables in there. We're gonna take some big old snips, some bolt cutters, or you can use some pretty thick diagonal pliers, but we wanna cut off about 1/4 of the length off of the shaft. So it's about 1/8 inch we're cutting off here. About that much. Perfect. And then that will be cut so it's the same length as the toy motor box thing here. So you want those to be the same length. Maybe you cut mine a little short, but when that gets installed, you don't want it to poke into the rest of the gear. So if I were to install this, you can see that I've got about 1/16 of an inch, got plenty of room there. And then because I cut it up, it might be a bit burred on the end, so I'm gonna kind of deburr the very end. I'm also going to scratch up the motor shaft such that I can get some super glue on there, and we're gonna glue that gear back on. Now, what you can also do, I found, to make it even more robust, which we'll do in our production model, is if the gear for some reason comes loose, like there's not enough glue or just heats up over time, it can sometimes like to slide down the shaft. And so if you put a shim on that brass collar, it'll prevent the gear from sliding down the shaft. So our production model will have that improvement. But all we're gonna do is put a drop of glue on the shaft there, nice generous amount. And then we're going to put that gear that we took off the original gearbox and put it on. It's gonna be really tight, so what I like to do is support the back of the motor on the back of the shaft, just like that. and then really gently and carefully tap it on. Make sure it goes straight on. If it goes on crooked, you could end up actually breaking your gear. So very carefully, I'm gonna tap straight down. See it sliding on, getting shorter until it hits just about the end of the shaft there. Then if we reinstall it, hopefully we'll see that it lines up correctly. So if I were to push it all the way in, I can see that the teeth of the gear beneath it line up pretty well to the middle of that gear. So I just about nailed that. So once I've verified that length, I will go ahead and remove the rest of the gearbox assembly. These gearboxes have a handful. I mean, they're like, you can get these for literally 99 cents. But because of that, they're not the most robust with the plastic housing and the gears. So we're gonna do some reinforcements here. So what I like to do is, first, I will reinforce the motor shaft on the smaller gear set. So I'm gonna take the original shaft, I'm gonna toss that. I'm not gonna use that anymore. And I'm gonna take my 5/64 inch drill bit, and I'm gonna drill all the way through the motor shaft on the housing, both on the top and the bottom, right in the middle. Take our 5/64. And I'm gonna, as straight as I can, I'm gonna drill that in the bottom. A little crooked, but that'll be okay. And then I'm gonna drill the top, same thing. Try to keep it straight. Okay, and that just makes it so the axle can now go all the way through and have more plastic surrounding it rather than just going just the depth of what was there, which on the top one, it was really shallow. So we've got that reinforced. Next, we're gonna make room for our new motor. You may have noticed that the 130 motors that mostly be used, you can see that I found some that they're actually really tight. They don't quite fit, but you can see the tabs will be in the way. So I'm gonna cut down those little tabs on the back here. So I'm just gonna use my snips or my diagonal cutters and just cut that so they're out of the way. This is mostly just a quality of life thing, which you don't really have to do. And then since we're gonna replace the top screws with these wider ones, I'm gonna drill out the top cover holes so that way I don't get any biting on the top cover, but they slide into the top and bite into the bottom. So I'm going to take my 7/64. Again, you may not find this necessary if you're an experienced builder. Maybe your gearbox came out, but depending on your gearbox, your blue gearbox, sometimes I find that the holes are really stripped or already stripped. So that helps, that replacing these screws in advance means we don't have to worry about that being a problem later. So those screws fit. We're good to go then to reassemble our gearbox. But as we do, we're going to shim the motor. I should also mention you should have a 2mm by 22mm axle. This will be your new axle to go in the middle. So what we're gonna do is we're then going to replace the axle and reinstall the gears. So we're gonna push that down. It's okay if the axle sticks out the back, that is okay. But we're going to replace the gears in the way we found them. So we're gonna put this one on first. Let's make sure it still spins. Then we're gonna put this guy on. Get some of that dust out of there. Put the large gear on. Then we're gonna put the other smaller gear on, and then this one on top to seal it off. And then finally, we're going to then put in our motor, but we want to shim the motor because if you did notice before, the collar here is a bit wider than the default one, so it doesn't quite fit perfectly in the box. We found the easiest way to do this is just to shim it rather than trying to cut the box out perfectly. So we're going to take a piece of electrical tape. What I like to do to find the best amount of shimming is to cut about a square out of it, then to fold it in half. And we're gonna put that on the back, kind of back third. Put that on the back third like that. Then we're gonna put our motor on. Just like that. Then we're gonna do another electrical tape square and put it on the front third. Right there. And then we're gonna replace the cover. Now that new axle should go through the hole. It'll be nice and tight on that motor in the back, and then we can reinstall 2 screws. These are the 12mm shell screws, not to be confused with the 10mm shell screws that also came in your kit. Slightly longer shell screws, and then on a low torque setting, or tighten them until just they tighten down, either by hand or low torque setting. Very low torque setting depending on your drill. I kind of know my drill, so if you're familiar with your tools, it should be okay. If not, then just do it by hand, and there you go. You can see that the motor doesn't quite sit all the way closed, and that is fine because, like we said, we shimmed it and the motor was a bit too big, but the rest of it should be flat and closed, so you have a nice seam. And then finally the shaft, the motor shaft, I want to push down so it's kind of flush to the top of that housing. It's okay if it's a little loose, because we're gonna have extra room in the back, but not on the front. So there is our blue gearbox, reinforced, ready to go. Solved a lot of issues we've had, but these are just $1. So if you have issues, you could just swap it out for a new one. You can get it in packs of like 8 for pretty cheap online. But if you don't wanna have to constantly take your LMG apart, this seems to be the best way to do it. That being said, we can set that gearbox aside now and work on to the rest of the build. Next is we're going to assemble the switch mount. We're gonna start from the gearbox, work our way out. And so we're gonna do our switch mount printed piece. And I'm gonna do it in the order I'm gonna do it. But again, the order doesn't matter too much. We're gonna take our 10E switch and drill it out to that 7/64 again. I like to do this. This is optional, because then our shell screws, like we said before, will fit perfectly in the holes, just because they're a little bit wider than the holes that are in it already. Then we're gonna take our Phillips and install the 10A switch onto the switch mount. So the rest of like the Phillips screws I would install, which should be the cage. So make sure my cage is clean. You might have some burrs in there. You want to knock those out. Clean up the cage if you need to. And you can use the dual stage cage for a single stage setup, because we have these cutouts in the slots where the dart just falls right through. If you are worried about that, you could always use our dedicated single stage cage. But for now, I'm just going to take my motors. I'm going to make sure that they fit in the cage. So the collar on the motor should go all the way through the hole in the top. And if it's a little tight, you can again file the hole out a little bit. I'll try this one. So that one fits all the way in. You see it sits up nice there, almost flush to the top. There you go. Both motors sit where I want them to. So then I'm going to gently pop them out. I'm going to apply just a drop of this blue thread lock to each of the motor mount screw ports. And then I'm going to install in the polarity as shown, with the cage on the back, the front to the left. I'm going to put the red facing the left, and then the other red facing the back on the, like that. Push those through, make sure they go all the way in. We're good. And then take my motor screws, install those. These, try to torque them down so that way they're fairly flush with the top of the cage. They won't be all the way flush, but again, use our most recent files and the screws will fit better. You can see that this one is slightly coming up. That'll be okay if it's about 1 millimeter sticking up. But ideally you'd want these to be biting into the motor, so you can feel the torque holding it, or feel the torque on the screw holding the motor into the cage, but not so much that you end up stripping it. So a little sticking out is okay. You just have to sit your wheels higher. We just will offset our wheels so they are spaced evenly. So if you look at this, when we install our wheels, we want to press them straight on to make sure we don't accidentally bend the shaft. And push straight back, as far back as we can, and if we spin it, if we push it on too far, we'll hear that the motor is rubbing on the motor screws, but I don't hear that now. And then I want to put the next one on so it's sitting at the same exact height as the first one. So I'm going to push it straight on to make sure that it doesn't bend the shaft. Push it straight down, make sure it's the same height. And this one looks a bit lower, so then I'm going to very carefully take something, I like use a flathead screwdriver or something just flat, and then while supporting one side, I will then gently pry up on the other side of the motor. Try to get like an even force as we pull up on it. If you pull it up too high, then you can kind of lower it again. You can even like use something to shim it to make sure you don't push it down too far again, but you want to keep pushing it down until it sits level with the other wheel. Yeah, there you go. Those are pretty much perfectly balanced now, pretty close. And then you can see that they should line up to pretty close to the middle of the barrel. That doesn't matter as much. And then our barrel's still clean. And there's our cage with our Phillips screws done for the build. So we will then move on to installing the rest of the gear assembly here. So to do that, we're gonna put our cam gear onto our shaft. We're also going to need our housing piece and our gear. So this gear, make sure you print it nice and thick. We use really thick settings because we've had multiple times where it strips the gear. You know, if you get a jam or something, then we just get the inside of the print stripped. So nice 6100 print here. But we're going to line that up to the shaft and we're going to press it on. If you have a vise, that'll work, or if you have an arbor press, even better. Or if you just have a hammer, then you'd want to put the back of this flat side onto a surface to then hammer straight down, because you don't want the gear sticking at an angle. A little bit of an angle will work, but the more perfect, the better. That went on a little crooked, but that worked much better than I thought it would. I usually use a press for this. You can see that it went in crooked because you see some of the plastic kind of got ripped up in the process, but that'll definitely work. There you go. And then we'll install into the housing. So I'm gonna make sure my housing print is free of supports and debris. And this is why I've got my handy dandy 13/64 drill bit. There you go. Got a hole there and looks clean. I'll put the gearbox with its gear into the slot of the housing. Then attach those two with an 8mm screw here. Yeah, so just make sure you use an 8. We try to do it so you could tell the screws apart. You know, the original design maybe used an 8, a 12, a 10, or an 8. I'm saying 8, a 10, a 12, a 14, and a 16, and an 18, whatever. But yeah, now they're significantly different in length, so you can tell them apart. But we'll put an 8 in here with a 2mm driver. And then again, you see the shaft. We don't want the shaft poking out the shaft of the gearbox because you'd have the gear on top of it, but it can stick out the bottom and be okay. And that way you just get maximum axle retention. And then we'll put the switch mount onto the housing, and we'll use a 10mm into the hole in the back. I'm going to keep this here for demonstrational purposes. Grab another 10 here. Okay, there we go. Don't over tighten anything, you might end up stripping something, so just tighten till you feel it tighten down. And then we're gonna put our switch presser on with a 25mm screw, I believe. Just like this. I wanna be a little careful here because depending on how your prints came out, if your screw threads into a different piece first, you may end up getting the prints to actually separate and then it could break rather than going through the holes. So make sure your screw is going through the holes. A little more torque on that. And I want to make sure my switch pressure still has room to move. It's not too tight. I'm gonna go all the way to depth and then back it out a tiny bit. And you can't really test that because my gear is all squished up against there. But we'll test that once we get some power through it to make sure that switch presser freely rotates. You could actually cheat and run power through to it now, just for funsies. See? Yeah, we got plenty of room. That switch presser definitely moves, so we're good. The next step is we're going to assemble the rest of the frame to put this presser switch housing motor thing in. So we're going to take our shell are this one. And again, if you need to clean up any of the holes, 13/64 works great for that. We removed some of the excess holes that didn't need to be there. We also changed a few holes, so use the most recent files and you have the best time. But if not, you can still get it to work. Just might be a little bit less smooth. I'm gonna clean up my holes there, making sure I can see them and access them. All the holes look good. And then for now, we're going to install some screws to act as the mount for the housing. So 222s will go here. I'm gonna install these into depth just until the heads are nice and recessed. 22 in there. 22 in there. And then the pivot for the trigger is gonna go in here. Also a 22. Okay. And then we're going to install the gearbox assembly with the holes in the blue gearbox onto the 222s in the middle there. Might be kind of tight depending on how straight all the screws are, but that one dropped in. Then we're gonna keep it installed with another 22 up in here in the top left corner. There we go. Then we're gonna install the trigger. Just drops onto this 22 that acts as a pivot point. Okay, trigger on here. Nice. Then I like to use our long skinnier compression, a long skinnier compression spring for the trigger return spring. We got lots of excess spring, but that is how we like it. I don't like how crunchy it is though, so I'm gonna rotate that spring to make sure that it lines up a bit better. There we go. So that way my spring goes in and out of the hole without being too crunchy. It's an extra long spring because that's the way it's designed. While we're working on the frame parts, the stock gets installed. So I'm gonna install the stock parts next. So my stock and my butt place release are gonna go like this. I'm gonna use my about 1/2 inch narrower compression spring. And that just sits like that. And this gets two 14mm screws. Again, I'm gonna make it so my springs don't crunch on me too bad. So 14mm, it's gonna be a hair longer than my 10 on either side. Now, if you over tighten these, you can get a butt plate release that doesn't actually release. So keep them loose enough that they release. There we go. That works. And then we're going to install this into the frame as so, with a 22 on the top and a 14 on the bottom. You can use shorter screws if you want. This is the 22 is the longest length you can get without it going too far. So just about as long as you can go. Maximum thread retention, over-engineered, all that jazz. So 22 and a 14 in the bottom. And then before we finish off and close everything up, we're gonna do our pusher assembly next, which is gonna be our, I guess what he calls the launcher. And you can see that I've got a little bit of gunk in there in the hole where that spring detent goes, fingerprints came out. So I'm again gonna take my handy dandy 13/64 and clean up that hole. It should be a couple millimeters in depth. There you go. Now it's a cleaner hole. If it focuses and you can see that at all with the lighting, but maybe not. And our launcher face, aptly named, and our pusher. So I'm gonna make sure our pusher fits without too much friction. See, it's got some friction in there, too tight. You're gonna wanna file. I usually like to file the outside of this thing and the inside of this thing, but we'll see how much we need to do. Again, most recent files will not have this problem. So if the pusher goes in here and the face goes on here, yep, that'll work. Okay, we're gonna put another compression spring, the long, narrow one. I'm gonna put that in the hole that we cleaned out in the launcher. Or just set it in there, and then with the pusher, we're gonna get it lined up to that hole a little better. We should see if we have enough. Yep, it moves back and forth, we're good. Then on this one, we're using these M3 flatheads, which have a 2mm hex drive, which is kind of annoying because it's not the same as all the other screws. But you could use a Phillips, similar size screw, Phillips head instead, or just use a 2mm extended driver. And we're gonna put a M3x10 flathead into the top. Do this instead. Then we're gonna do one into the bottom here. Way easier than a hex key because it got that pusher in the way. There we go. And we should see the pusher now retracts. So if there's any jam, it helps the gearbox not strip. All those reinforcements shouldn't have any problems. Then the last thing is we're going to install the springs to retract the launcher. I find that it's really good to use the same spring as a caliburn. I like to loop these together, super quick and easy, because if you get a really long extension spring, it's actually a lot more expensive than just a couple of short ones, and you only need enough tension that it will reset after a certain part in the cycling timing. So it turns out that when you have some slop in it like this, in between each spring, it actually helps because you have no tension, and then tension, and then you have force. So you have a point where you have excess room where you can collapse without any tension, which actually turns out to be helpful. And I actually found some builds, some custom builds in China or whatever, that their springs actually have gradient coil distance, such that you get gradient or variable tension depending on how much you compress. Anyway, so that we're going to stick into the back of the launcher. Should be a perfect fit. Keeps it nice and tight. And then you can see the loop. You want a loop of the first spring to be in the hole, so that way you can then put a 14mm through it. So another M3x14. And you want that to go into the hole of the spring, and we're good. Then that gets installed into the frame. I like to use a 10mm M3x10 to go through the spring into the hole that we put on a raised block. To help keep the spring from getting too bendy and sounding terrible. So you can kind of hear it slide. But if you back it out a little bit, we'll make that little block taller. That way it's less crunchy. Use our most recent files, but there you go. Then we can wire the thing next. Is the soldering. So this is not a soldering tutorial. If you don't know how to solder, I recommend you find one. Want a nice good tip, nice and hot, get it nice and clean. You want to tin it to make sure the tip is nice and clean, conducts lots of heat. Then you want your 14.5 inch, and you're gonna put that onto the back of your XT60. Normally I'd use a clamp for this, or helping hands, or a vise, but I'm just gonna freehand it. So I'm gonna tin, see the positive, on both sides. Tin the positive, tin the negative. And I'm gonna put the red wire onto my positive end. So then I've stripped off a little bit of the wire, about 1/8 an inch. And then I'm going to tin it. And then I'm going to install it into the positive side of my connector. There you go. And then before I solder the rest of it, I'm going to do the black one and some heat shrink. I like to use about 1/4 inch, 3/8 heat shrink. Okay, so stripped twist tin, solder to the negative, then install our heat shrink. Heat shrink just helps keep the connection a little stronger and prevent short circuits. If you're worried about that kind of thing, optional. You can use a lighter or a heat from a soldering iron or a heat gun to melt the heat shrink. And then we're gonna put the end of each of the wires through the stock, or you could put the XT60 through the other end. Whatever fits your fancy. I'm gonna do the XT60 way. I don't know why I did that way. XT60 through your stock. Then we're gonna solder the rest of these joints. So we're gonna solder the 14.5 inch end, the red one, to our 21A switch, which should have the lever removed. If not, then you can just bend the lever up, pop it off. We're gonna solder that to the shoulder, the top of the shoulder of the side of the switch or the COM. So I'm gonna strip and twist my wire. I'm gonna tin my wire real quick. Then I'm gonna tin my 21A at the shoulder. Then I'm gonna connect those together. This is not a professional soldering tutorial, but I make it work. Now I'm gonna install this with an M3 by 14 up here by the trigger. Just tighten it down until you feel it tighten up. You don't want to strip it. Then we're going to do the rest of this soldering. So we're going to go with the black wire. So pulling on the slack to make sure I kind of have the same length on the black and the red. I'm going to then connect the black wire to the pusher negative, which is the one without the red dot. So I'm going to find that length and I'm going to strip off a section of that wire. And then I'm going to tin that section of wire. And I'm going to solder it into the negative of my pusher box. Make sure you don't accidentally melt any of your prints while doing it this way. I like to do it this way because that means you don't have much wires hanging down, and I find it generally easier to assemble. But you could always do all the soldering first if you want to do it that way. If you're worried about melting prints, good enough. And then the black wire will just come out to the next connection, which is going to be this top one here. So measure that, strip, twist it, tin the wire, tin the tab. There you go. The rest of this is going to go out to the motors. I'm going to kind of rearrange my wires here and make sure they're kind of laying flat, a little cleaner. And then we're going to do our pusher positive onto the bottom connection or the COM of our pusher switch. So that 1.5 inch wire, strip and twist both ends, tin. Then we're going to tin the tab of the positive pusher tab and the COM of the pusher, or the one closest to the bottom of the hinge. Solder that to the positive pusher and then to the pusher switch COM. And then finally, we're going to do our last red wire. That's going to go from the middle of the pusher switch. So strip, twist, tin the wire, and then tin the tab. And then this wire going from the middle of the pusher switch is going to then come over to connect to the bottom of the 21A. So make that length, kind of measure that, round up, strip section, twist it, tin it. And then I'm going to tin a tab. I'm just going to do it onto the bottom side of the tab here. And then connect that to that. There you go. That's all the soldering. We should be good to go. And then close the cover. And then again, I'm going to rearrange my wires to make sure they're kind of neat and tucked in. You don't want the wires to get pinched up by the launcher, but we should be okay. Then we're going to close it off with this other half of the frame. We're gonna put this on top and make sure the wires come out to the bottom of the pusher there and not to the side. Oop. In between the pusher and the bottom. And then we're gonna do the same thing here with a 22 and a 14. 22 up top. 14 on bottom. And the last screw here on the back side is gonna be a 25. So we're gonna put a 25 through this side. Make sure you don't accidentally go through a wire, but you should be able to take that 25 and go kind of around the wires. So make sure that, I'm gonna try to make sure I don't go through a wire, so I'm gonna put the screw in front of the wire. And go through the other side of the frame and just tighten it down so I can feel it tighten down, and we've got that going. Not too shabby. And again, it's gonna be a black wire, wanted to get on top of the pusher there. So we wanna make sure that those wires stay in their groove. Otherwise your pusher's not gonna have a good time pushing. Slide it back down. I will make those wire guides a little bit more pronounced. If you over tighten the screws, your pusher will not move. So beware of that. And now we can move on to the rest of the fun build, which is the grip and the front and the handle. So we're gonna do our grip next, our box release, and that's going to be, you can see there's a hole. It's gonna be another 1/2 inch small compression spring. Line those up with 2 more M3x14s. The original files, the release would often get stuck, kind of like that. It's getting stuck a little bit, but it still comes out. So we're good. Then that goes on to the grip with more M4x4 or M3x14s. So I'm just testing to make sure the trigger isn't stiff. Again, if you over tightened it, then the trigger won't reset properly. We're running out of room, so you might zoom out on our frame here, but we're gonna grab some more 14s. 4 14s to do the grip. As always, it helps to hold the prints together as you put in screws to make sure everything is aligned right. So yeah, so at this point, we're gonna finish off this middle section and work onto the cage. So we're gonna grab our frame R with an 8x8 and a 10. So that 10 goes here. 10 in front. Then we're gonna do the feed guide, all the feed guide stuff, and then the cage that connects to it. So we're gonna get our feed guide rear. We're gonna get our belt retainer. And then we're gonna use a full size of our wider compression spring. Same one inch length, but it's wider. And we're going to get an M3x25. So I'm gonna put that in there. Put the spring in the retainer, line up the spring to the spring detent hole, whatever you want to call it, and then 25, M3x25. Make sure it lines up, make sure, yep, looks good. And if you look at a link, you should have the link. Let's put a dart in a link. This link's a bit gross, but put a dart in a link, you should have the link line up, and the retainer will retain the link without moving to the side. So use the most updated files and things will line up better. We're going to install the feed guide front. That's just with 3 M3x10s. If you use the original files, be careful though, because if you use a 10 on the original files, it'll actually poke out into the belt retainer and prevent the retainer from moving down, cause you jams. As I say this, I'm not like knocking the original files or anything. I mean, the first LMG, you know, amazing, but there are a few things to look out for, is all. Unless you use the most recent version. These things may or may not have been fixed on the original files. When I say original, I mean prototype files, perhaps. So now we'll do our cage. So we're gonna feed the wires through the bottom here, and then this will just set in here like this. Again, if you tighten it too much, you won't be able to get it in, but there you go. I guess we could mount this first and then do our cage. So let's mount this first. So we've got this side here, we're gonna do 14s up here. Then in here, we're gonna do 2 8s. And make sure everything all sits nice by pressing it together. Okay, and then now we should be able to do the cage. Now we got that all locked in there. So I'm gonna tin the tabs of the motors. And then I like to do the positive on the front. Well, the positive needs to go on the front. And then I like to have my wires coming out this side because that's the direction that I'm building the blaster towards me. I always build my blasters this way. So I'm just gonna take the positive, strip, twist, tin, the positive to here. Give it a second to cool. And then I'll do the negative, strip, twist, tin. Then I will make a little bend in the wire, find that length, and then kind of round up. Again, strip off a segment, twist it, see how it lines up. Then you're gonna tin that section that's gonna connect, and then pull it across. Do the same thing with my negative, strip, twist, measure, tin, pull it across. That's all the soldering. So if you're confident you're soldering, you turn your iron off now. And now this is the interesting part. Depending on how the cage mounts. So you can notice the cage is kind of be floating loose in there, and it's being mounted in by the side panels. So you want to make sure that your cage is not crooked in between those side panels, otherwise you'll get shot to the left or the right. Which is kind of cool because then you can adjust it. You want to shoot to the right, you can kind of like tighten one side, loosen the other, move it left or right, but ideally you want to shoot straight. So we're going to mount that then with the flywheel cover, starting with the right side, so the side that we already started. And that's just going to go like that. And we're going to do the screws in the order before we attach the barrel shroud. So it's going to be a 22, a 22, they're all 22s, into the side. But you can notice that there's going to be some gap in the front there, and that's where your play is going to come in. So we'll do a 22, we'll do a 22 into the first hole here. This is where I need to zoom out, crazy. And that should go into the cage. You can feel it bite down. It's not gonna go very tight though. There you go. Just in case it's gonna strip, I'm gonna not go too tight. Then another 22 here. 22 in here. Then if we get the front lined up, like those corners there, and we can see that the 22 is gonna go into the cage from the side. Well, you can see that the screw is just going through nothing right now. So if you use our most recent files, we would have bridged that gap. But because it's going through nothing, that can cause the cage to move. You can see it moving right now. So if you heard about the LMG shooting sideways or backwards or all through, that's usually why. And then we can't do this front one yet because we got to put the barrel shroud on. So we're going to do that now. And that's just another 22 though on that bottom hole. So if that looks like it's lined up pretty good, pretty straight, I'm gonna put that cover on and do another 22 in the bottom corner here. And then the rest of it is going to be a 25 up here, because this one's got to go all the way kind of through the cage. I can't show you. It goes all the way through the cage. This 25 does, and then 2 8s. Let's check the alignment, see if the cage moved. You want to see if the cage moved. There you go, in that circle there. And you want to make sure that the cage is pressed all the way down here as well, so the screws line up on the other side. But yeah, that's how you do your cage adjustment there. Tuck these wires in, do my wheel cover left next. So same kind of layout for the screws. Gonna be 22s on the bottom, 25 and 8/8. Then we're gonna do this other piece here. What's it called? Side panel left. 8 in the back, 2 10s up front in this cover here. So we'll do an 8 first. I'll get that sitting nice down flat. Sometimes depending on your prints how it came out, it can be a little challenging to get that to sit in there. And then 2 10s here. Again, you sit nice and flat. And that is also something that could cause your cage to get crooked, is that there's a gap in here. I put this panel so you can see now my cage is leaning to the left. If I take this out, yeah, it's not leaning to the left as much. So you want to tuck and adjust as you go, or use the most recent files. So with that all done, the main body, we can then move on to the cycling the belt cover, which is the doozy part. And our hinge, which is 2 M3/25s. Again, these go all the way through. You can use shorter screws if you want, but this ensures you get maximum thread length. Just like this, make these evenly spaced. Yeah, that piece is pretty centered. And then we're gonna do our innards, or top rail, I guess, and then inwards, whatever you wanna do. So top rail. So the top rail, the wider section goes in the back, so that way the rail lines up fully to the belt cover, and that gets installed with M3/8s. And then the inside of the belt cover, you have the cover release with these little pieces. They go with the larger button kind of side down first, one on the left, one on the right, one on the left, then another long and narrow compression spring. I like to set one side in, and I pull it in from the side. And then put the spring in the little cutouts, little circles. They have to be perfect. There we go. Then the rest of the cover is, we want to make sure that our moving parts slide freely. We have a lever, our cam, bolt retainer. Just want to make sure that the F goes this way. So we want to make sure these parts slide freely together, nice and loose. Then want to test this guy. Yeah, so if it rotates, see, it doesn't get stuck right there. Nice and smooth. Here's the goal. Okay, and then we'll do an 8mm screw with the F towards the groove here and facing up. So here's an 8. Tighten it down until it kind of tightens down, and then loosen it so that way it still gets nice smooth movement. So I should be able to kind of flick it, and it shouldn't really favor one side or the other. Nice and loose. Then we'll do the cam. Same thing with a 10. I like to make sure that the 10 fits in nice and loose. Yep, so when I tighten it down, it'll still pivot. Back it in, loose it out. You can see it still flicks pretty smooth, going both ways. Gravity, yep. Then last but not least, we're going to assemble our belt retainer with our belt puller, or our pawl as it's called, with another wide compression spring. And we're gonna assemble that together. That's gonna be an M3 by 22 screw. M3 by 22 in the side. Then we're gonna put our spring. Let's see here. There we go. Put that in there. Push it down. Make sure that spring stays in the upright position. And then, yeah, make sure you get full range of motion there. Looks good. And then that goes just on the round nub. See, I made the other nub not round, so it wouldn't be confusing. Into the slot, and it should still, again, gravity should make it slide. So you should be able to drop it through, back and forth. There you go. As smooth that is, that's what you want. And then we'll do our feed guide. Just line up the shapes. Oop, this way, can't line up the shapes correctly. And then 2 more 8s. Okay, and then when that's on, we're going to install our springs now. So we've got some cutouts for some springs into the belt cover. So we're going to take our 4 wide compression springs, and we're going to put 1 into each slot. That one's going to be kind of loose, but it's not going to go all the way to the edge. So it's going to be loose now, which makes it easier to install now. And I should say I like to use tweezers for this because it really helps if you can squish the spring and then insert it in there. It doesn't like rotate on you or anything. I guess you could install a spring before putting on the cam as well if you're struggling. If you have a good set of tweezers, it'll go a lot faster. So I might go grab some. You just have to like compress it and then slide it. So if you compress it such that both ends are, there you go, see that? Both ends are compressed, and then you can slide it in the slot. Boom. Then make sure that it's straight, there you go. Then do the other 2. So working smallest to largest, I suppose, is easiest. Just like that. Then when we put on our bolt assembly, it'll keep the springs from falling out if they're a little loose. We're gonna assemble our bolt with our cam roller, the 10 millimeter. Make sure that it sufficiently spins on this guy. Yep, there you go. You don't want to over tighten it. And then we're going to do the same thing we did before with the extension springs. Grab 3 extension springs, connect the loops. And again, that's what we want, is where there's no tension and then there's tension. So that way in the last tiny bit, you don't have to worry about the tension. Anyway, let's slide that all the way down into the very last hole so we can see the loop of the spring. And then we'll put in a 22 to hold it in. Just like that. Then we will install this into the cam system. And then before I connect the spring, I'm going to install my bolt handles. So our bolt handles, we're going to use M3 by 35 and an M3 by 25. We're going to put an M3 by 25 on this side. I'm going to put a screw all the way in. And then I'm going to put that through this side. And this is important because it will determine part of the friction on the cycling is where these are positioned. So like we want this to be close to the side here and a bigger gap on that side. Otherwise, like it might sit crooked and not function. Then the 35 goes on the other side. And you can see that'll be much longer, so we can reach into the bolt sufficiently. And this one you just don't want to over tighten, so you still have a gap. So the bolt moves up and down. Then we'll connect the spring to the hole with an M3x10. Then we should see the whole thing is not going to function. So it'll usually have some resistance going back, where it'll kind of get stopped, and then it'll go the rest of the way. So if you let go, it should bounce all the way back. And some of it has to do with the friction on this corner here, hitting onto the rail of the angled slope here, so the orange corner. So you can deburr or file this corner down. Or you could also lubricate the moving parts. And you can see now that it's already moving smoother. We'll see sauce there. So these are newest files. We'll put some of that in there, but a lot of times the 3D printers have a hard time making smooth surfaces without that ghosting or bulging on the corners. So now you can release it. It goes all the way back, super smooth. That's what you want. Least friction here, the best, because that way we can put all the force we need into actually pulling the belt instead of overcoming its own friction. But that's the belt cover. And that installs onto the rest of the blaster with 2 more 22s, which is our last 2 22s. Then make sure that opens and closes. Open, close, all locks in, fully cycles. One thing to test for though is when you manually cycle it forward and you lower it back, you want to see how well it fully resets back and the belt puller doesn't get stuck kind of halfway, because what happens is that this handle could go all the way back, but the belt puller may have a few millimeters of travel, so you want to make sure that the belt puller is fully going all the way forward and back. Looks like it gets stuck down on the front there. So that's probably because the bolt is probably rubbing on the yellow frame here. So I want to make sure that we kind of break it in and make sure things sitting straight. And we can adjust it if we need to. Some fine tuning though. So then we've got the carry handle and all that jazz. So the carry handle gets reinforced because it is kind of a thin print here. So we do some screws to reinforce it. So we're just going to do some more. I'm going to do 2 25s to reinforce the carry handle. That way you can swing it around and not worry about breaking. And then the carry grip, we're just going to install that with a M3x10. Just enough so that way it's on, but loose enough that the grip still pivots. So I'll loosen it a little bit. It's fun to have the grip rotate on you. Okay, and then we're going to put in our carry handle with our mount. Then we're going to do the barrel-y stuff. We're going to put on the barrel shroud piece, the handguard. We put on the handguard, and we're going to put on the barrel into that. Right side facing out. Barrel and handguard goes in the front. Then I'm going to do 4 10s to hold that together. 10, 10. Then we're gonna do our barrel coupler and gas block. Gas block just goes on top of the carry handle mount, and then barrel coupler goes on top of that in this orientation. And that should line up such we can do another 10 in the bottom here. Clean up that hole. It's a bottom hole. Do one more 10. And that should go into the barrel as well. I do like to line up the barrel groove so that you can see through the barrel. I think that's kind of a cool effect. And then you can screw on your silencer here, your muzzle, your whatever you want to call it, your orange tip for safety. And there's the LMG blaster. Now the stock, the butt plate that goes on the back here, it just gets assembled with 2/8. And the hook part goes on the top of the stock. And then, last but not least, is our ammo boxes and the cheek rest. Cheek rest is pretty easy. Ammo boxes, also pretty easy, but that's just a lot. The rest of our 10s and 8s, so we're gonna do one wall per can in the orientation such that the counterbore holes for our screws are facing to me, and those are gonna be 4/8s. And then the latch, or the top part, I will install with 2 10s, and it goes on with this flat side facing this cutout in the can top with 2 10s. I'm gonna put one in and get it lined up to my hole. I'll do the other. And the can top, we'll just go onto those holes on the side for the pivot. Here our prints came out, it can be a tight fit. We'll push it on. There you go. And that's 2 more 8s. So these don't need a whole lot of force, really. They just kind of act as a pivot point. And there you go. Bumblebee color scheme on this one. Then real quick, the second can. It should use up all the rest of your screws. Probably just super duper extra 100 back worth it. I will do that. Okay. And then finally, the cheek rest. We'll just do 2 thumb screws on the cheek rest. So now we'll get to the troubleshooting portion if it doesn't fire. So we should have a mostly charged battery here. Fully charged battery does best. So first I'm gonna open the cover, make sure it revs, and as I assemble it, I try to make sure my wheels rev the right direction before I put it together. But if you follow my build guide verbatim, you should be okay. Making sure that the flywheels don't rub on anything. And then make sure that the pusher, I like to make sure it cycles, and then make sure while holding forward, make sure that the motors spin. Then with it closed, final test is the cover. Oh, so we had a problem where it didn't fully reset. And that's probably the friction, like I said, on the bolt. So it's not coming all the way back, which is usually because the cam is stuck somewhere, it's like stuck like we had it before. So I'm gonna adjust that. So To alleviate some of the friction, I'm gonna look at it and see where it's rubbing. So it's probably the orange piece rubbing on the side here, like we filed down a little bit, as well as the cam and all that. So I'm gonna just drop some lubricant in those moving parts and check, because the bolt might be rubbing on this yellow frame. So if we file down a little bit of the bolt, throw some lube in there, in addition to adjusting the cover, make sure the cover is sitting flat and it's not angled to one side. It has more friction when it's closed than when it's open. So we're gonna fix that. So I just poured lube on the mechanism there, on the cam. Oop. Probably poured a bit too much lube, to be honest, but I just poured it, you know, opened it up, poured it in, and I kind of did a handful of drops wherever it was moving, and it seemed to do a ton of difference, make a huge difference. So yeah, the belt puller is going all the way back in. We'll load some darts and we'll test it. So to load the links though, remember they are directional. So you do have this an arrow on it, and I load it this way. So with the arrow to the right, with the dart to the right, with the arrow facing me, with the 2-prong side facing down, I load it as such. So we've got 10 links here now, varying quality, varying colors, varying shape, size, and version. So full disclosure. Oh yeah, we're getting some inconsistent feeding. Well, it's not pulling the link in. So back and forth typically. You know you're getting full travel on it. Otherwise, if it sounds kind of mushy, then there's probably too much friction in the bolt returning that's causing the bolt on the top half to not fully reset. If there's too much friction on the bottom half, that usually means that you're gonna strip your gearbox. But if you get the top bolt kind of in the middle area, then that wouldn't be translated to friction on the bottom half, because you only get that friction in the last little bit of portion there. So if you're not getting fully reset bolt, that's a different story. But for that troubleshooting, that's what that did. Let's try it now. Beautiful. That actually came out great after I put those modifications in on the feed. I'm still not getting quite full travel on the square links. The round links work better, which is weird. There you go. Now you have fun.